Hey, RubyConf. For those of you who don't already know me, my name is Kerri Miller. I'm a lead developer at Blue Box Group. We have a table in the vendor booth. I'm obligated to mention that. Failure for Fun and Profit is the title of my talk, and I thought I was being ironic when I named it Fun and Profit, and I saw there were 3 other talks named that. It's kind of a silly title, really, because I'm not really going to be talking about failure, and I'm only tangentially going to be talking about profit. What I am going to talk a lot about is having fun and how you go about that. Failure isn't fun at all, and none of us really want to fail, and none of us expect to fail, and yet we take risks every day. It's really important for us to take these risks because that is really the only way that we ever learn anything, by pushing our boundaries and seeing where the edges of our knowledge are. If you're not making an absolutely glorious, exhilarating mess of your code on a nearly daily basis, you're not really progressing your knowledge. You're getting to done, but you're not expanding. Nasruddin said that good ideas come from experience, and experience comes from bad ideas. So go have some bad ideas, get some experience. It sounds a lot to me like the scientific method. When we're not acting like scientists, we're not really pushing these boundaries. We're not creating a hypothesis. We're certainly not testing anything, and we're never actually really adjusting our results to account for the new information that we have. The scientific method also is the agile cycle as well. The real purpose of the scientific method is to make sure that nature hasn't misled you into thinking you know something you don't actually know. Robert Prisig said that in Zen and the Art of Motorcycle Maintenance. And it was really this book that got me back into programming. After a 5-year stint at Amazon, I took 2 years off and became a poker player. And I didn't really know how I wanted to proceed. I was stuck. I was absolutely stuck, and I wasn't having any fun. And then I realized that I can know anything I want to know. I merely have to approach it in the right way. You need to ask questions that you think that you have answers to already in order to validate that information, to see that the world hasn't changed out from underneath you. I mentioned being a poker player. I have a few other hobbies. I was a sous chef briefly. I'm a long-distance hiker. I spent 1.5 years as a marionette puppeteer. I fix vintage Vespas. I'm a self-represented glass artist, which means I get a check from Etsy every week. It's usually single digits, but that's okay. I put that up there not to say like how cool I am, because I think my hair shows that off pretty well. But the point is that consistently I've always struggled with being a novice, with being completely out of my depth and not knowing what I'm doing. And so often I see people struggling against the same exact problems. How do I progress forward? How do I learn something? Getting stuck on problems for weeks at a time. The experience of being outside of your element is scary, it's intimidating, and in the end, it's absolutely thrilling. You need to find that fun in that moment. Mihai Csikszentmihalyi said, "Not all experiences may be particularly pleasurable at the time they're taking place, but afterward we think back on them and we wonder why they last. What was really fun about that moment? We wish they would happen again." An enjoyable event we know has changed us and our self has grown. Why do we stress about learning? Why do we stress about not knowing what we know and not knowing what we don't know? A little Rumsfeldian moment there. It's difficult to look foolish in front of peers on GitHub or Twitter, and we certainly don't want to look foolish in front of ourselves. It's scary territory to find ourselves in. But inside of all of us, there's a reason why we got into this field to begin with. Because we wanted to solve a problem, because there was something interesting to do. I think we also all remember being children on a playground at some point. And none of us really knows or cares how many games of tag we won or lost. But we had fun when we were doing it. So why can't we have that fun with our work? Really, it's the risk. It's the risk of failure. It's the fear of it all. If you want to learn something new, reduce that risk. Take away that fear. Redefine failure into a data point rather than an event that happens to you. Find the excitement that got you into this to begin with. Go back to being a kid on the playground. So what I want to talk to you right now about, though, is how I became a pool shark in about a week. When I showed up at Blue Box, I immediately saw that we had ping pong tables, kegerators, and a pool table. And now I love pool. And I did mention I was a poker player for a while. So I spent a lot of time sitting around at green tables, betting money on the cards, and listening to people talk about golf or sports betting and pool. And classically, being a pool hustler and a poker hustler go together, right? So obviously, I have to go become a pool hustler. It didn't really work out that way. I played a lot of pool, sometimes for money, but it was never very good. 6 months ago, if you saw me in a bar and you challenged me to a game of pool, you were going to win. That simple. So the first time I showed up at Blue Box, I said, hey, come on over here, play a game of Calvin Pool. Calvin Pool, what's that? I mean, I know 8-ball, I know 9-ball, I know cutthroat. Calvin Pool is a game that our principal technologist invented with his brother when they were kids, and they were bored one afternoon in a basement. The rules of Calvin Ball are really, really simple. When it's your turn, your opponent picks out the ball that you have to hit. That's it. You have to shoot the cue ball, hit the ball your opponent chose for you. That's it. You don't have to sink it. You don't do any magic. You don't care. The next shot's going to be just as hard. It's absolutely amazing. It's so much fun. I can't even tell you. I got better really, really fast. I lost the first 5 or 6 games. Yeah, but I got really good. I was holding my own and made some impressive shots. People don't want to play Calvin Pool with me anymore. That went on for about a week and a half. And I went out with friends, and someone said, hey, let's play pool. I'm like, cool. So I broke. The ball went in, so it's still my turn. I sink another one, another one, another one, and I ran the entire table. I don't know if you know this or not, but if you sink all the balls in a pool game before your opponent even hits one, that's pretty impressive. So that's another game people won't play with me. Calvin Ball, or Calvin Pool, is a great demonstration of how we redefine failure. I was forced to make these impossible shots over and over and over again, and no one ever expected me to make it. And even if I didn't make it, big deal. It's my opponent's turn. I get to screw them. That's wonderful. I could try anything I wanted to. I could try a crazy hop shot. I could put English on the ball and see how it reacts. I could do multi-cushion shots. It simply didn't matter. I was free to explore side effects. I was free to try the most insane thing possible. Learning a new programming technique for me is just like that. I challenge myself to learn through exploration and trial, to have fun with it, to define it down until I'm just learning the one thing that I want to learn. I do it over and over again. I practice. I don't warm up. I push the edges. So why does taking this emphasis off of stress and failure actually work for our brains? You're probably familiar with the left brain, right brain split. The left brain controlling math and logic, the right brain controls art, music, language. In general, this is pretty accurate. It's a little more complicated than that, but it's a good model. These sides of our brains are really delicately balanced. It's difficult to use logic and paint a picture. It's difficult to write a poem and do quadratic equations. You can focus on the shot in front of you, or you can worry about how you're going to get home from the pool hall. Learning requires both of these kinds of thinking, though. You need to have imagination and reasoning. Learning, in the Platonic or Socratic sense, is the discovery of truth. You take two abstract ideas and you make a connection, and then you integrate that reality into your perceptions of the world around you. You rewrite the algorithms that your brain uses to perceive reality. Cognitive scientists working with chimps were testing how these chimps reacted to stress by stressing out one group of chimps really badly, turning the lights on and off, changing the temperature, kind of being a little mean to them. And the other group of chimps were really well treated, given their favorite bananas and fruits and everything. Then they're presented with a pattern of dots on a card and given a treat whenever they could pick that pattern out again from a series of patterns of similar dots that are shown on a screen. Slowly, scientists would introduce variants on the original and reward them for picking those out as well. The groups performed equally well at doing this task. It's pretty standard. Scientists were, whatever. They took a break. They came back 2 months later and reran the experiment. The relaxed chimps, the chimps that were given the really great environment, they picked it up like that. They knew exactly what was going on. The chimps who were stressed out, they couldn't remember that they were going to get rewarded for performing this task. Rats going through mazes have similar effects as well, and scientists have isolated this effect down. Small amounts of stress before we succeed lead to long-term, lasting memories of that success. While large doses of stress, the kind that you get when you're just like sitting around for days at a time, eating bland oatmeal and having the lights turned on and off, that's horrible for forming happy memories. When stressed, the brain prioritizes the here and the now for survival. It engages the fight or flight response. Stress hormones flood the brain to increase our response time, and that doesn't allow our brains to process the feeling of this was good, which is required for setting up abstract memories. So Calvin Ball did exactly this. It removed all of the stress, all of the risks involved. It put the emphasis on having a great time, having a beer after work, shooting a little pool. Everyone's expected to fail, and we're trying to be mean to each other. It's all part of the fun, and we have an escape valve. We can leave that game at any time. When we're stressed at work, we can't leave. We simply can't just walk out in the middle of a hard problem. For our brains, this kind of control, this kind of lack of pressure is really, really powerful. We seem to be wired to learn stronger memories more quickly from fun, exciting, stimulating environments than we are from stressful ones. We're designed by nature to flourish through play. In fact, we're one of the only social animals that has a hierarchy structure that encourages play outside of childhood and adolescence. Wolves, whales, tigers, lions, they all have play as children where the normal rules don't apply. But as adults, they become very strict societies. We don't have that. Our brains remain plastic well into our old age. Engaging in this kind of play appears to be critical for the development of the brain and continual learning. Johann Huizinga was a Dutch philosopher, a cognitive linguist, a cultural theorist, a little bit of physiologist, and he actually taught art history as well. He did most of his work in the early 20th century, and in 1938 he wrote this really super influential book called Homo Ludens, or Man at Play, in which he posited that the act of playing is an event which occurs within a specific boundary of space and time, in which the normal rules of life don't apply. Play is done for its own sake, and we play because it is fun. Play begins, and then at a specific time it ends. And this sort of pulling ourselves out, pulling our brain out of the everyday world, creates an outlying event that takes on significance. So, if we want to create specific memories that are static and stay longer than just the humdrum every day, did you take the bus? Did you get coffee this morning? We have to encourage this sort of play. We have to give ourselves space to play. We have to give ourselves space to fail. We have to take these glorious risks. We need to minimize intrusion and distractions, the things that pull us back to our normal world. When I'm trying to learn something new, I go to the Pacific Science Center in Seattle or the aquarium where they have Wi-Fi, and I just sit down there and look at octopi float by or the laser show. Not because the bandwidth's any better or it's less distracting, but because it's different and it takes me out of the normal reality that I have. We also need a lot of time to learn things, which is unfortunate. But if we can give ourselves a solid block of time to say, this is different, this place and this time is separate from our reality, to truly explore these side effects, we can sandbox and reduce the risk to ourselves if we actually do fail. We need a lot of courage. We need to give presentations at conferences. We need to rock climb. We need to use a different version of Ruby. So much of our daily life requires us to be domain experts and to find the exact precise solution to a problem because a client is on the phone, or there's a deadline, or there's some kind of pressure and something's on fire. Everything can be a threat then, and we'll never get past just getting done to really integrate the knowledge. If we create the play space, we create new rules, and we need to embrace them. We need to be confident that what we're doing in this time and place is normal, and it's okay, even if we're acting as children, as novices. So I'm a liberal arts major. I actually have 2 bachelor's degrees, both in liberal arts. So this is a really familiar slide to me, and if you are at all familiar with, Western storytelling at all, you know about the hero's myth. And this is the Joseph Campbell, Carl Jung exploration of what is a story in Western society. We start with a hero who's in a place of known, their little village, their little town. Something propels them outwards. There's a problem. There is a giant beanstalk that's growing up into the sky. Something challenges them, and they have to face a crisis. The giant's coming home early. They get a gift of some sort, and then they return to their normality. They come home with the golden harp, or the goose that lays the golden egg. And they're forever changed by that experience. Their world has been expanded. Something is new. This guy, he's just having dinner one night. And these guys show up and say, "You're hired." Cool. And then we face some trials. And then there's, some challenges and riddles and puzzles to solve. And then there's a magical gift. And then we return home, and everything's different. And the cycle continues. Learning is like this. Learning is a heroic act in which we're voyaging out into the unknown and we're seizing fire of knowledge. We are Prometheus in this moment. And we can be burned by that. Or we can face it down and we can integrate it and have fun with it and be playful. So what abysses are there? What is the unknown what are we afraid of? This is pretty bad. When we're afraid, our brain can find distraction in anything. When I start with an empty screen with no distractions, that's pretty cool. I've shut down Twitter, obviously. Everything is gone. Everything's quiet. It's nice. I'm at my local library. Got my noise-canceling headphones on, maybe a little Skrillex, just a little bit. And this starts. What am I going to do? What do I want to learn? Oh, well, I want to learn TDD. I want to do, this JRuby looks cool. Where do I start? What do I do? I have a pull request I got to review. And I got a wedding I'm planning for. I should send an email about that. This happens to all of us. This is our brain trying to distract us. Our brain is afraid. Fight or flight is starting to kick in. It's pulling us away. It's saying, this is a scary place that we're in. We could fail. What if I write bad code? What if I don't write any code? I've just wasted an hour. I could have been being productive. I could have billable hours right now. Why am I doing this? If you give yourself time to get past this, if you can be courageous and humorous about this, you can actually watch your own brain trying to self-destruct and implode. And then eventually it'll pass, and you'll be able to get on with your creativity and your learning. So you limit your distractions, you set aside time for yourself, you step outside of your normal constraints, and you're all set, and you know what you want to study. You're seeking this passionate moment of knowledge, of the heavens to open up, an idea to strike you or a piece of knowledge. Aha, I know this. This is awesome. We've all had that moment where you suddenly, you're looking at code and you're like, oh, I get how this works. Or I understand maglev. I understand why this would be great, and I know how to use it. What we're seeking is called an aesthetic experience. Sir Ken Robinson is an education reformer in the UK, and he coined the phrase aesthetic experience and defines it as one in which your senses are operating at their peak when you are present in the current moment, when you're resonating with the excitement of the thing in which you are experienced, when you are truly and fully alive. That is an amazing place to be. We've all been there. It's called flow. Mihai Csikszentmihalyi said that flow is the enjoyment that appears at the boundary between boredom and anxiety, when challenges are balanced with our capacity to act. In trying to have an aesthetic experience, we walk this balance beam between anxiety and boredom. We're pursuing flow constantly. We don't have control over our skill here. We have no skill. We're at the far left, maybe over by the S, depending on what we're learning. What we can control is we can control the challenge, though. At a pool tournament, you stare at the table and you try to figure out the shot, all the various complexities that are coming into play. Where's the cue ball going to end up? Is this going to croom off? Am I going to end up with a scratch? Am I shooting at the right ball even? Oh my God, it's a solid, but it's the 8 ball. Where's the money going to come if I lose this match? In Calvin Ball, the entire set of options were narrowed down. All the variables are removed except for make this one shot. Why can't we do that with learning? We have too many options sometimes. We have far too many choices. I want to build an awesome Dagobah playset, so I go to the Lego store. Where do I start? I didn't get into Ruby for about 6 months because I couldn't get MySQL support to compile. Couldn't do it, and I was hell-bent that I was going to use MySQL, and that was the only way it was going to be. And I let that stop me because I got caught up in the choice of technology. I went down the rat hole of so many of us go to. What do I name my gem? Man, like what's going to be cool? Is there a Twitter account for it? Oh, it's okay. Shoot, I got to think of something else. What's on TV? That pull request is still waiting. These things like really, really knock us off key. And so we got to define some limits for ourselves. We got to pick an unfamiliar technique. We want to find something that we're unfamiliar with. If you're doing something normal every day, humdrum, try Haml a little bit instead of ERB. Maybe you want to use Redis instead of Mongo. You want to try and make life hard for yourself, but not too hard. You want to stretch. You don't want to break. You want to find what's just out of your reach and grasp it. This gets into deconstruction of problems, where you want to break the problem down to the smallest possible pieces and remove those variables. Find a simple and obvious task that you understand and just solve it. Then solve it again, but do it differently, with a different technology, or redefine the problem. By taking the problem apart, the technology that you want to learn, you're going to be able to find divergent thinking, alternative ways to get to that solution. You're going to be able to see how those techniques really, really apply to getting you to done, and be able to compare from version to version exactly how they influence your path and your journey from start to finish. And that will allow you to really integrate that knowledge and bring it forward. This is a user case that I use when I'm doing mentoring or working with people after they go through RailsBridge. This is a really simple user case. It's disturbingly easy. I've actually gotten into interviews. It takes 2 minutes of Googling to get the algorithm. 2 more minutes, you're going to find a repo full of 8 different ways to solve it for 20 different languages. You're going to find arguments about what the most efficient way to do it is, why you need to do it. We don't really actually want to solve this problem. We want to focus on how we solve it. We want to pick a variety of ways to get from start to finish and see how it changes our path. These are 6 different ways that I've actually solved this problem, and each of them gave me something new to solve, a new area of technology to explore. Have I figured out the base user case of temperature conversion? It doesn't matter. It doesn't matter. What matters was I made it a gem. Cool, I learned a little bit about how Bundler works. So then I did it with Jeweler. And I could see how these different tools affected my workflow and the final product. It's easier to have a detached approach when you use these simple problems, the focus of what you're trying to do. Make an exhaustive list of everything you might do, and the last thing on your list is what you should do, which is a paraphrasing of the Oblique Strategies cards from Brian Eno and Peter Schmidt. There were 55 cards that the 2 of them came up with while Eno was recording an album and Schmidt was there painting away in the studio. That's what you did in the 70s. Some of the cards are things like use an old idea, emphasize the flaws, work at a different speed. What would your closest friend do? I have a set of these that are more specific to technology. And I use them when I'm stuck, when I don't have an idea, or when I want to solve these little tiny problems, but I don't know what I want to do. I'm out of ideas. So what would my closest friend do? How would he solve temperature conversion? It's kind of interesting. Could I write code that looks exactly like his, so he wouldn't even know if he pulled my code into his project? Things like that sort of propel you forward and make you think about the problem. Because ultimately what we're doing is we're building models. We're building these little toys that are fun and exciting to play with, or they should be. We don't really care if they break. We're kids in the sandbox with our toys. We've got Greedo over here and Princess Leia, and they're flying in a TIE fighter, and they're going to somehow shoot down the Millennium Falcon, and that's okay, because it's just fun. At some point, though, with childhood toys, we did start to care, because they became valuable, or they took on emotional significance. And so these little toy problems that we should be building and we should be playing with, similarly sometimes take on a little bit of value, because we start to see like, yeah, I solved that problem really, really well. And now I want to do something with it at work because I have a need to convert temperatures. You know, maybe the fans on our servers only respond at Celsius and all of our code works on Fahrenheit. Well, then it becomes collectible. And you can put it on the shelf like a toy and stop playing with it, let it collect dust, hopefully rise in value. Our version of that is, of course, putting it on GitHub, seeing what happens. It might collect dust. Someone else might find value in it. But we should show it to our peers. And we'd say, hey, what do you think of this problem? What do you think of this solution? Is this interesting to you at all? So that's what I did with FizzBuzz. Everybody know FizzBuzz? Anybody not know FizzBuzz? No fear. FizzBuzz is an interviewing question that got really popular about 3 years ago. You take the numbers 1 to 100 and print them in order. If the number is divisible by 3, print fizz. If it's divisible by 5, print buzz. If it's divisible by 3 and 5, print FizzBuzz. It's really interesting, but it's a really fascinating interview question, or at least it used to be before everybody knew about it. And I thought its heyday had come and gone. And then I interviewed at a company, and I got asked the question, and I was like, oh, weird. So I solved it, and there's a couple little tricks. You know, I got past it. And I interviewed for another senior dev position. I got asked it again. I got asked it 4 separate times in 2 weeks. I'm like, man, this is a horrible question. This is like, why are manhole covers round? You know, everybody knows this is the solution. Why are we bothering? So I was here I was in Boulder, actually, and complaining about it. And my friend said, well, why don't you just solve it once and for all? And then you can like put the URL on a business card and just say, pfft. Next question. So I did. And I had a laugh, you know, and I posted on Twitter, now announcing FizzBuzz 0.1. That was fun. I went into work the next morning, and one of my devs came up to me, he's like, you know, that was pretty cool, but you got a bug. Oh, crap. That was super embarrassing, so I released version 0.2. That's funny, you know, you released the second version of your joke gem. It's on version 0.5 right now. 0.6 is going to go out next week. It's got a full test suite. I ripped it down and rewrote it with mini-test, for 0.4. It works on all these versions of Ruby. It's got Travis CI, code climate built in. Well, not built into it, but it uses it. Wonderful, wonderful code metrics and benchmarks and timing graphs to show you that 0.5 is awesome and 0.6 is even faster. It's mixed in. I've done some really wild flights of fancy with it. And that's fun. Because I have all the joy of FizzBuzz now. And of course, so do you. Because FizzBuzz.io is the world's first FizzBuzz API. I don't care what Twitter says. It cost me $79, and I'm proud of it. But you can get your FizzBuzz results in JSON or XML or HTML, of course. I don't know why you'd want to, because it's a service. So that's funny. But there's more. Yeah, so I had to go learn Facebook logins. That was a pain, so I did it for FizzBuzz. This version will passes out using AQMP to EC2 instances to process FizzBuzz results. It doesn't matter. It doesn't matter that it's just dividing by 3 or 5 or 15. It doesn't matter. What mattered was, how do you use a message queue? How do you spin up a EC2 instance and then process? It works with Twitter. It's got its own Twitter account. I managed to get that. It's got SMS and email delivery built in. It's great. So you can actually send me your FizzBuzz results. I better turn that off. Again, each of these was an experiment. Each of these was a spike in the traditional sense, not a spike of, let's work really hard for a day and turn out some project, but let's spike. Let's just do something and see, what are the effects? What does this technology mean for our legacy code base or the greenfield project we're working on? We're going to throw it away, so we don't care about the execution. What we care about is the path and the journey and the knowledge that we gain along the way. We care about the gifts that we get from Gollum and how we're changed when we get back to our village. So not everybody has time for this. A lot of us are really super busy. We have projects and clients, and maybe we're searching for jobs, maybe we're going to school. That's okay. There's other ways to supercharge your learning besides doing something funny. Pair programming is amazing for this. I don't pair program enough. I don't get to, as much as I'd like to. But every single time I do, I learn something new. And when I do, I write it down on a separate little Post-it note so that when I can get back to my desk, I can go read a man page. I saw somebody use get re yesterday or earlier last week. Anyone get re? Rebase? Weird. Record, replay, rebase. It's an amazing command. But I would never have found out about that. I found weird flags on grep. I've been using grep for almost 20 years. Where did that come from? As I said, I do actually teach at Railsbridge quite a bit. And young women always come up to me and say, I want to get a job. I'm just a student. What do I do next? I don't have anything to show. People want to see my GitHub account. Experienced developers do this too, especially if you're working in a closed source shop. Well, go adopt a gem. Go find somebody else's FizzBuzz. Hands off mine. But go find somebody who posted a 0.1 or 0.2 of some passion project that doesn't do anything, that's 300 lines of code and doesn't do anything except print herpaderp. It doesn't matter. You can find something to refactor about it. I know you can. Or add tests for it. Or something. Write it in a different language. But do it and then send it back to them as a pull request. You'll have made their day. You might make a friend, an internet friend maybe, but you're going to learn so much about seeing somebody else's code and working with it. The other thing I really encourage you to do is teach. Go teach something. Go teach something to someone else who doesn't know it. I mean, don't grab somebody and I want to teach you something. Do not come find me and try to teach me something important, like how to speak at conferences. Teaching acts as a focusing lens. It's exactly like rubber ducking. And the reason that it works is we have all these abstract, logical ideas in our head about how programming works, about how computers talk to each other. And as soon as you have to engage with the person, you're flipping over to the right side of your brain, where all the empathy and social cues and language are. You're taking this logical thing, you're turning it into an abstract thing. In that process, you'll be like, I don't know how to explain this. I lack the language. And you're going to learn a lot by the questions that the novice asks you, far more than you're going to get by doing the same commands over and over again. Two other things that I don't have slides for that I really tell people to do is go to a study group, find people online to go through Ruby koans with you. I'm starting a group in Seattle for Project Euler problems, where we each fork a repo, and then we submit at the end of the week, this is my solution to this mathematical problem. How many people are familiar with Project Euler? Some of you, okay. It's a set of a few hundred mathematical problems, and the goal is to basically solve them in the most efficient way possible. But I can say, hey, here's my solution. And I can see yours and go, oh yeah, mine sucks. Or maybe maybe ours are both equally performant, but in different ways. And so I'm gonna learn a technique from you, and you're gonna learn a technique from me, and we're gonna have a conversation. It's not only good for us as individuals, but it's good for us together, and it's how we start to build that community and keep that community going. The other idea in that is to start a book group. It's a little Oprah-ish, but there's something really great about reading a book like Goose or Sandy Metz's Practical Object-Oriented Ruby. Go read it and come together in 2 weeks and talk about it. Because ultimately, this quote is the point. Chuck Close said this. He was a photographer in New York City, is a photographer, I suppose. And he's done some amazing work. And he speaks quite a bit about inspiration. Where does he get his inspiration? And I first came across this quote because I said to a boss, I'm just not inspired to work on this project. And he looked right at me and said, inspiration's for amateurs. And he walked away. I was like, oh, so sad. And I looked it up later because I thought he was a genius. And I found he just stole the quote. Inspiration's for amateurs. The rest of us just show up and get to work. When you do the work, you will become ready for when inspiration does strike you. If you just sit around waiting for a great idea to write in JRuby, or how you're going to rework with Ruby 2.0 and Rails 4, you're not going to be ready for it. You're not going to have the skills to actuate your ideas. And most inspiration actually comes from when we are doing something, and we start to see these connections between these concrete things, because that's how humans learn. We know hot things burn us. We know that pots are hot, ergo, pots burn us. Two concrete things, two concrete facts that we know, connected by an abstract connection. Because ultimately, that's what it's about. Humans are the ones that look out and say, what's there? We're the ones that say, yes, but what's next? Where do I go from here? What's around the corner? What's over that horizon? If we just stay in our safe place, if we just stay on the shores of our knowledge, if we never set forth and find out, are there actually dragons there on the map? Then we're never really going to know, are we? So that's me. It's been fun. Thank you very much.